yet. Oh, there it is. Okay. All right. We can get started here. I see you sent 3 pictures. Which problems do you want to start with? Looks like we've done some of this already, though. Possibly
11 through 19 odd.
11 through 19 odd. Okay. Determine the intervals of the domain over which the function is continuous. Okay. All right. So these pictures didn't come in great, but so I might have some questions for you as we're working through it.
Yeah, I can
Um,
clarify it for you.
so we're gonna paste in question 11, and we'll get started here. So it's asking where it's continuous. You're looking for continuous. Some people say it's like being able to draw without lifting your pencil.
Mhm.
So imagine you just draw something like that. That's continuous. Okay. Um, there is a calculus definition, which we're not going to get into because you're not in calculus. Um, but like kind of like most of math, you're looking for exceptions, and there's really 2 exceptions that you're looking for. The first is a hole. So literally, like the function comes to a place, and then there's an open bubble.
Mhm.
The second is a vertical asymptote, not a horizontal, but a vertical asymptote. So this is something where the graph is coming up and it goes like that, and then there's a something like that. That's the vertical asymptote here. So one way to look at it is, do you have any of these exceptions? Like in this problem, there are no exceptions as far as I can see. So this one is continuous over the entire domain of the function, which is minus infinity to infinity.
Okay.
Let's look at another problem here. I guess we'll cue this one up and see if,
Number 13.
yeah, so I'm going to get that pasted in here. And this one, again, the graph isn't great, but it looks like it starts there at 0, 3. It looks like it's a filled in bubble.
Mhm.
So if you just use that first thing I said, which is the pencil test, just can you draw it with your pencil without lifting it up? Yeah, you can. And the domain of this thing is from 0 to infinity. It's the x value. And this is the interval over which it is continuous because you can draw it without lifting up your pencil. 15, which I'm going to paste in next, it's got a really good example of the vertical asymptote. So notice there's a vertical asymptote. I can't read that value. I'm going to assume it's at -3 though.
It is.
So that's a separator, and that's where the function is not continuous. So one way to write it is saying not continuous at x equals -3, but that's not what they're looking for. They want to know the domain or the interval in which it's continuous. It's minus infinity to -3, and then -3 to infinity, and then between them we use the union symbol to demonstrate that. Um, I would like to just grab one here for clarity. I know you're just trying to get this done for getting this turned in, but for just the purposes of learning here, there's a hole. There's a hole
Mhm.
here. There's a hole at x equals 1 comma 3, and that's the other type of discontinuity that we're looking for. There is a third. It's called a jump, but we'll just consider this one here. So it's just like an asymptote in the sense that it's a breakpoint. This hole is a breakpoint. So your interval here is minus infinity to 1. It's always the x value, 1 to infinity, and then you're just excluding that value of 1 there.
Hmm. That's interesting.
All right, can we move on to the next set of questions here, or is there anything else on that section that I should cover?
On the
17.
number 17 and 19.
Okay, so 17 and 19, they're different. They're asking for a bunch of different things that you can ask about with a graph. So 17 here, I think the first thing that it asks for is, where is the function increasing, decreasing, and constant? Those all kind of go together. So it's increasing if it's going up and to the right.
Yeah.
So here there's kind of that break point is 3. So it's increasing from 3 to infinity. So everything to the right of 3, it's going up and to the right. It's decreasing when it's going down and to the right. So just to be clear, that's part A. Down and to the right. So it's decreasing.
Like minus infinity to 3?
Exactly. And it's constant nowhere. So you're maybe thinking, well, maybe at that point 3 it's constant. Well, it's actually neither increasing nor decreasing. Doesn't necessarily mean that it's constant. We'll see that in the next question. Constant is typically a horizontal line.
Oh. So C is not applicable?
Not for this one.
All right. Now for D, give the domain in the E range.
Yeah, so this one is kind of, you would actually want to do this first. So the domain here is all real numbers. There's no place where there's a break or discontinuity.
For the range, should it be something like 0 to infinity?
Exactly. It is a bracket 0 to infinity because it's included.
Oh, bracket. Okay. 0 to infinity. All right. On to number 19.
All right, on to 19. So 19 is the problem I think you would see on a test because it has all 3 of the increasing, decreasing, and constant. So this is a good one for us to look at and get comfortable with. So it's increasing when it's going up and to the right. There's a breakpoint here at 1, and a breakpoint here at 4. Sorry if you can't see that real well, but it's so where is it increasing? Well, it's increasing, and usually you have to say that.
Is it from negative infinity to 1?
Yes, and then decreasing from 4 to infinity. And then it's constant. This one's kind of easy because it's in between those two. It has to be doing the other thing, which is being constant. If this were multiple choice, you would see a lot of variation on like on the answers because it it's not clear. They might use the X or the Y values incorrectly. Excuse me.
Is the domain still all real numbers?
Yes.
And now E. Then we got range. Should be like, what is it? Negative bracket 3 to negative infinity? Or no, never mind.
Negative
I had
infinity
that
to
backwards.
3. Yeah.
All right, negative infinity to 3. There you go. And then bracket over to 3. All right. Now let's go on to number 35.
35. All right, I have to get caught up to you here. So we're going to a different page. 35. Symmetric with respect to the x-axis, y-axis, or the origin. Okay. Okay, so this has y-axis symmetry, and the reason is I have to sort of tell you before you can understand is if you take either the left side and mirror it, like imagine this is a mirror, does it look like this on the right side? Yes. Or if you take the right side and you mirror it to the left side, does it look the same? So that is how you do x-axis and y-axis symmetry. It's the same idea. You just make sure you write the correct axis. It's whichever is the mirror is the axis. Are we doing odds here again?
No, we're gonna do 35 through 42 all.
Okay, so 36 has x-axis symmetry. You'll see that come in here, x-axis, because it's kind of a, this is a good format to do it because you can see my cursor moving this part when it's reflected over this mirror. It looks like this part down here.
Oh, x-axis symmetry. Okay.
So 37 you can almost make up some rules like x-axis is like top, bottom, same. Y-axis is left, right, same. This is usually pretty intuitive for most students, so I've actually not spent much time kind of thinking of better ways to explain it. But this one has x-axis symmetry again because it's top, bottom. What's interesting is that they can actually have more than one, which we'll see coming up, but 38 is something a little bit different. So
the origin symmetry.
It is, or point symmetry. This is actually a rotation. So if you take this part that I'm highlighting on the right and you rotate it 180 degrees, and you can either go clockwise or counterclockwise, it doesn't matter. You'll end up getting this other piece over here.
Will 39 and 40 be the same thing, still be origin symmetry, or is it something completely different?
They actually have all three.
They have all three?
Yeah.
Oh, they do. How would you label it though?
Just I would say that they all have it. They have x-axis, comma y-axis, comma origin symmetry. So these have x-axis, y-axis, and origin symmetry. One of the problems with these is these aren't actually functions, so they're completely a visual exercise. Usually you ask whether a function is what's called even or odd, which is what we're doing here. When we talk about it having y-axis symmetry or origin or point symmetry.
Therefore, 41 and 42 be origin symmetry.
41 is, but 42 is not.
Oh, what's 42 then?
Well, is 41 clear? Because like sometimes what you have to do is you have to almost like cover up the left side, and like or the like it. So this one is origin. What did you do in 42? Like, did you mirror it over one of the axes or the others?
Oh, it's y symmetry, y-axis symmetry, isn't
Yes.
it?
Yeah. You kind of want to go through the progression. Like, is it x? Is it y? Is it origin?
All right. Now, on to number 53 through 59 odd on page 95.
Is that the same page?
Different page, 95.
Okay. I'm sorry. One more time. What were the numbers?
53 through 59 odd.
Okay. For each function, determine whether it is even or odd. Okay. This is a pure recipe type of problem. So you have to follow these steps every time. So the step one is you replace x with minus x. So it becomes f parentheses minus x equals, and then you substitute that in wherever you see an x. So it's minus x to the fourth minus 7 minus x squared plus 6. So here you're going to simplify, and you end up getting x to the fourth minus 7x squared plus 6. So there's a step in here I didn't say. Step 2 is to simplify. And then what you're doing here is you're looking, you're saying, you ask yourself the question, is this the same as the original? F of x. Is it the same? Yes or no? Like this and what we just found here, are they the same?
Oh yeah, they're the same.
So it's even. If the answer is yes, that means it's even.
I see.
If it's no, you have to do something else. Okay. All right. So I'm sorry. Did you say odds? So we're going to 55.
Yeah. All right. So this one will be yes, even.
So 55, same thing. You put in negative x in for x. And you really want to substitute with parentheses. if you don't, there's potential to make sign errors, and this is all about sign errors. So
these aren't the same, so it's odd.
No. That's the, you gotta, yeah, no. If you do that, that's incorrect. So it could be odd, but there's a little bit more to do here. So again, like you say, is this the same? And the answer is no. No. Okay. When it's no, you have an additional set of steps. The first one is you have to factor out -1. So even if it's positive, like in the front or anywhere, you still factor out a -1. So this becomes -1 3x cubed minus x. You agree with that? Do you follow that?
Yeah, I do.
Now, is this the same? Is this the same as the original?
It is.
Okay, so if you say yes to that, then it is odd because of that. And you need to see the neither case to know why you have to do this progression. So I don't see a good one here that's neither, but because really most functions are actually neither. So like, I need to do this here because you've got to, this is really important to learn. So let's make up functions. So let's say f of x equals minus x to the 5th plus 2x to the 4th minus 3x squared. Okay, so let's do f of minus x. So you get minus x to the 5th plus 2 times minus x to the 4th minus 3 times minus x squared. So when you simplify this, you get negative x to the 5th plus 2x to the 4th minus 3x squared. Sorry, I made a mistake here. Let me get rid of this. Okay, so is this the original?
This one? It sure is.
I'm sorry, this should be a negative out in front. Sorry. So
no, then it isn't.
So it's not even. Okay, it's not even. And then you factor out a -1. So you have -1 x to the 5th minus 2x to the 4th plus 3x squared.
That's different.
Is this the original? No, so it's not odd, which means that
it's neither.
Neither. Okay, and maybe this section only wants you to like have that binary choice, like it's either on or off, it's either even or odd. But the reality is like most functions don't fall into that category. So it's hard for me to be like, hey, this is okay. You know, it's like to learn it this way. So we can go to 57. I think that's next here.
Yep.
And maybe you've already got the answer to this one.
That one's different, so we have to factor out a -1.
Well, no, this one is the same. It's the same as the original.
It is?
Yep.
Oh wait, I did it wrong.
So you know, -x to an even is x, and -x to an odd is -x, and excluding any signs out in the front. So this one's even.
It's still even for number 59. I factored out the -1.
So when you factor the -1, you should get back to the original.
Yeah, I got the original for
that means it's odd. That means it's odd. So you.
Oh, I mean it's odd. Oh.
So if you put this in for if you likely said, okay, I got -3x to the 5th plus x cubed minus 7x, and you're like, this is not the original. So you factor out a negative, so it's not even. That's what you said. And then you factor in -1, 3x to the fifth minus x cubed plus 7x. Well, that is the original. And that's maybe where the confusion is. If this is the original, that negative out in front means it is odd.
Oh, all right. All right, I'm going to send you a picture of the next problems.
Okay. Great.
Do they send or no?
I'm checking every still haven't received anything. It's
Okay.
there it is. Okay, we can get started. Okay, so you sent 2 pictures.
Mm-hmm.
Which problem are we starting with?
Number 1 and number 3.
Okay, so the like find a cubic polynomial.
Mm-hmm.
Okay. Feel like we've done these before, just letting you know, like these look pretty familiar for us, but for sure go through them again. The thing here is that when you're writing a polynomial and they're giving you the zeros as they're giving here, the polynomial is always x minus the 0, x minus the 0, and so on. So here you've got a 0 of 4, and then you've got one of 2 plus I. These always come in conjugate pairs, which means that you've also got, which isn't written, 2 minus I. So when we write our polynomial of x, it's x minus 4, x minus 2 plus I, x minus 2 minus I. And this is, it's pretty important that you write it this way, where it's in parentheses, because otherwise it's really easy to make a mistake with signs, and sign errors are critical to getting these correct. So let's go x minus 4, x minus 2 minus I, x minus 2 plus I. So you want to expand these first.
All right.
Is this right? Okay, I sorry, I just saw you send another email. Okay.
Oh, that's the same. My bad.
All right. So the way to do this here is to take x and multiply it by each of the terms on in the right, the minus 2 each of the terms on the right, the minus I each of the terms on the right, or vice versa. It doesn't really matter. So it's x squared minus 2x plus xi. And then this, I think this is pretty important. When I multiply minus 2 times x, I'm going to put it below the x term. Minus 2 times minus 2 is 4. That's kind of a new category, so I'm going to put it over here. Minus 2 times I, I'm going to put that over here, minus 2i. And these need to line up to do it correctly and see the cancellations. Minus I times x is going to give you minus xi. Minus I times minus 2 gives you positive 2i. Minus I times I gives you minus I squared. It actually could go in this position because I squared is negative 1. So minus I squared is negative 1, which is positive 1. So you can end up combining all these things. So if you've done it correctly, all of the I terms have gone away.
Oh.
So plus 4 plus 1. The 1 is the I squared. And so your last step here is it's x squared minus 4x plus 5. Now, we're not done because you got to bring this x minus 4 down. So this x minus 4 is multiplying each of these. So you have to do this process again. You have to take this x and multiply by each of the terms in here. So you get x cubed minus 4x squared plus 5x. Then you take this minus 4 and multiply it by each of these. So minus 4x squared plus 16x minus 20. Then you combine your x cubed minus 8x squared plus 21x minus 20.
Awesome.
Now, this whole thing about there being a leading coefficient of 1, there's really an a in front of all of these. Like there's really an a here, an a here, an a here, and then there would be an a all the way down here at the end, but they're saying that a equals 1, so you don't have to worry about it. I'm sorry, I don't remember which is the next problem for us to look at.
Number 3.
Number 3. 5 and I are the zeros. Okay, so we know that we're going to write a polynomial function x minus the 0, and we keep doing that until we get them all. One of the zeros is 5. One of the zeros is I. What is the conjugate pair that goes with I? Do you recall?
Negative I.
Negative I. So our polynomial is x minus 5 times x minus I times x minus I. Always put those negative ones in parentheses. It just makes simplifying so much easier. You always want to work on the
I's first.
So it's x minus I times x plus I. This one's a little easier because it
cancels out at the end.
Yeah, it's just two terms. It's a binomial times a binomial. Last one was a trinomial times a trinomial. So you end up getting x squared plus 1. Again, that minus I squared ends up equaling positive 1.
Now multiply that by x plus x minus 5.
Yeah, and that's that's where you can get a little bit like, oh man, like there's a lot to do. Yeah, there is. These are incredibly long problems, especially if you have 3 or more. Plus x, so we got a minus 5x squared minus 5. So you end up getting x cubed minus 5x squared plus x minus 5.
Perfect. Let's do number 13.
13, okay. All right, do you remember synthetic division?
Yes, I do.
All right, try synthetic division on this, and let me know when you're done, and I'll catch up to you on that. This is.
All right, let me get this down. So we got 1, -1, -4, and -6. So we're going to have 1, 3, 2, -6, -10. Let's see. Find all remaining zeros. So I get like, what is it? X squared minus 2x minus 10, remainder -36. What do I do with that?
Okay, well, hang on a second, because it should have been a 0. It should have given you a remainder of 0. So
I done it wrong.
So
I think I put it wrong. Yeah.
So bring that 1 down. You're going to multiply. Yeah, so you should get something like this when you're all done.
Oh, that's why I did wrong. I added wrong. There we go. Done. 2, 0. Okay. Do we do anything further with this?
Yes, but we have to get to here first. So this is here's what we're up to. Since 3 is 0, it's always x minus the 0. So it's x. This becomes x minus 3. So what you just did, if you were to multiply these out, you would get back to the original.
Yeah.
Okay, which is not what we want to do. That's like taking 4 right turns. You get back where you started. What we want to do is further expand this. So you'd like to factor this, but it doesn't factor.
Mm-hmm.
So what is your option when it doesn't factor? Quadratic formula.
Quadratic.
Because what you're really trying to do here is find the zeros. The zeros is like solving. You know that solving is the quadratic formula.
Mm-hmm.
So we have A equals 1, B equals 2, C equals 2. So that gives us -2 plus or minus the square root of B squared minus 4.
Turns into like -4 in the square root.
Exactly.
What should it be when you like simplify it out?
So the important part is the inside parentheses here, or I'm sorry, inside the square root. So it's 4. It becomes the square root of 4 minus 8, which is the square root of -4. And do you know how to handle that?
Mm-hmm.
Do you know what that becomes?
Is it an I or something? 2i?
2i over 2. And then you actually divide each of these by 2. So it becomes -1 plus or minus I. So your zeros are 3, -1 plus I, -1 minus I.
All right. All right, now on to number 15.
Okay, so try this one again with synthetic division for either -3 or 3 to start, but then you want to carry on the synthetic division again with the other one. So if you start out with -3, then you want to do it with 3.
Mm-hmm. So for 15, I end up factoring it out to x squared plus 2x minus 1 times x minus 3 times x plus 3. And you simplify it out, and I get -1 plus or minus square root of 2. And the remaining zeros are -3, +3, -1 plus 2, -1 plus square root of 2, and then -1 minus square root of 2.
Okay.
Can we move on to number 33 and 35?
Yeah, of course. So it sound like you've got these down to work through. Okay, these are 33, 35.
Mm-hmm.
Oh, okay. So these are different, and I'm glad they give you the factored form here, so we can run through this. Okay, so the when you're graphing something like this, and I mean it's kind of weird that they're having you do this, because you can just go to the calculator or the internet and do this. So So at what this is telling you is that at 3 and at -3, there are zeros. So this is terrible, but that's at -3, and then that's at +3 right there.
Oh, okay.
Okay. Now, because it's even, because the multiplicity is even, you know that it touches. It touches but does not cross.
Does it do like that weird like little M thing where it touches it and then it goes through the origin and then it goes up?
Well,
Like,
we can do a lot to actually figure out exactly what this is, but the next thing to look at is the leading term to know whether it's because it's even. It either starts high and ends high, or it starts low and ends low.
okay.
So this one actually it would be considered a W.
Mm-hmm.
Because of that, because it does start high and end high. We can actually find this place where it crosses. It's 0, 81. I don't know how much of that you need. Again, you can, since you can get a calculator out or Desmos. I mean, it's kind of like, why are we even doing this? There's so many opportunities to just do this more efficiently, but that's what they're looking for. Basically, you have to find the zeros and then figure out whether it touches or crosses, and then figure out what the end behavior is to get the rough sketch. So, all right, let's move on to this one here. This is probably our might have a little bit of time here. Okay, so this one again, since it's factored, that's really helpful, because if it wasn't factored, we'd have to do all that. Sometimes that's what they make you do in these classes. They give you some zeros here. So there's a 0 at 2, there's a 0 at -1, and this one's at -1/2. So there's one at 2, 1, and -1/2. Okay. Now at -1, it's a power of 2. So that means it touches. At the other one, it crosses. So this one, the way I used to show this is you either make a U up or a U down, because that's touching. And then these ones either cross, like it could be one or the other. It's really better to go to the end behavior first. So this one, like
Mm-hmm.
the other one, it starts high and ends high. So when you get to here, since you know that it has to bounce, then you come up. Now this one is a cross, so it crosses, and then it has to cross here, so we know it comes up and does something like that. Now this is certainly not to scale, but it's what they're looking for in terms of the shape of like moving up, moving down, crossing, and so on.
Perfect. I think that one should take us to the end of the lesson.
Yeah, I would agree. So I'll connect back with you in about 10 minutes, and send me whatever you want to work on ahead of time.
That's good.
All right, thanks,
See you
Justin.
later.
Bye.
Bye-bye.